Today, we're talking about a climate pattern so powerful it can literally shake up the entire globe. It starts as just a tiny temperature change in the Pacific Ocean, but its effects, they can end up right on your dinner table. Okay, let's get into it. It sounds kind of crazy, doesn't it? The idea that a bit of warm or cool water thousands of miles away could decide if a farmer has a great harvest or a total catastrophe. But that is the incredible and frankly scary power that we are going to unpack today. And this isn't just some abstract thing for scientists to debate. As we're about to see, this phenomenon has some very, very real world stakes that can impact every single one of us. Okay, so what's really wild here is how it's all connected. It's a huge domino effect. You see, it triggers things like floods and droughts. That directly messes with agriculture, right? Sometimes the harvests are way too low, sometimes they're even too high. And that uncertainty sends shockwaves through our supply chains, making prices for everyday stuff swing all over the place. It even changes how much electricity we use or where we can find water. It all starts in the ocean and just ripples out. So, what is this powerful force we're talking about? Let's properly introduce the main character of our story, ENSO. ENSO, it's a bit of a mouthful, it stands for the El Niño Southern Oscillation, is a totally natural climate cycle. This isn't a one-time thing. It's a pattern that pops up every 2 to 7 years. And the key thing to get is that it's all about this massive dance between the ocean's temperature and the winds whipping across the biggest ocean on the planet. And this slide really nails the two personalities of ENSO. Just think of it like a giant switch. In one position, you get El Niño. That's the warm phase. The eastern Pacific gets way warmer than usual. Then, when the switch flips, you get La Niña, the cool phase, with unusually chilly temperatures in that exact same spot. Now, there is a neutral phase too, but these two, they're the heavy hitters that cause the most drama around the world. So, how do scientists make it official? How do they know when an El Niño is really here? Well, they use this key metric called the Oceanic Niño Index, or ONI. You can basically think of it as a thermometer for a very specific and very important part of the Pacific. And when the temperature in that zone stays at least half a degree Celsius warmer than normal for a few months straight, boom, an El Niño is declared. To really truly understand the power we're dealing with, we gotta look back in time. Because the history of ENSO, it's written in floods, fires, and sadly famines. This quote, it's from a scientific paper looking back at past events, specifically the monster El Niño of 1982 to 83. It's just a brutal reminder that behind all of this data and the charts, the human cost can be absolutely devastating. Just let these numbers sink in for a second. Over $8 billion in damages. And that's in early 80s money. In Peru and Ecuador, they didn't just get a little more rain, they got 40 times the normal amount. It was catastrophic. Meanwhile, on the complete opposite side of the ocean, places like Indonesia and Australia were bone dry, battling these insane droughts and deadly fires. It just goes to show you how one event can unleash polar opposite disasters on the world at the exact same time. So, given the stakes, you can see why trying to predict these things is one of the absolute biggest and toughest challenges for climatologists today. Yeah, one of the big reasons it's so tricky is this thing scientists call the spring predictability barrier. Basically, every spring in the Northern Hemisphere, the whole climate system just gets, well, chaotic. It makes it super hard for the models to see what's going to happen months later. It's like trying to pick the winner of a horse race when all the horses are still bumping into each other right at the starting gate. It's just a mess. So, keeping that forecasting challenge firmly in mind, what are the models telling us right now about the second half of 2026? Wow, okay, here it is. This is the headline number. The International Research Institute, which pulls together a ton of the world's best climate models, is putting the probability of an El Niño developing by the summer of 2026 at a whopping 80%. In the world of climate forecasting, that is a very strong signal. And this table here, this shows us how they got to that number. Just follow the El Niño column. You can see back in March, April, May, the chance is tiny, only 9%. But then look at the jump. Just a couple months later, from May, June, July, it rockets up to 72%. Then it peaks at that 80% mark in the summer. So the models are all showing this really rapid switch from neutral over to a pretty confident El Niño forecast right in the middle of the year. But, and this is a really big but, this is where it gets super interesting. Science is almost never a done deal. While all those mainstream models are screaming El Niño, there's a very recent paper using a totally different method.
It's based on things like climate networks and complexity theory, and it's telling a different story. They don't see the same signals at all. In fact, they think a neutral event is actually more likely. So what we've got here are two credible but totally conflicting views of the future. Now, this disagreement, it's not just some academic squabble. These two different potential futures mean vastly different things for all of us.
And this brings us right back to our dinner table. If the mainstream models are right and a strong El Nino shows up, we could be looking at the kind of agricultural chaos we saw back in '82. Key farming regions could face drought, others could face floods, and that could really mess with the global supply of staples like wheat and rice. On the other hand, if things stay neutral, the global climate won't have that one big bossy influence. That can mean more normal weather, but it can also make it harder to predict what's going to happen in any one specific region.
So, as we watch the Pacific and the world's most powerful computers crunch the numbers, we're left with this huge question. The difference between these two forecasts is the difference between a year of relative calm and a year of potential global upheaval. It's not an exaggeration to say that the world's food security could be hanging in the balance.